Hello, my name is Steve Merkel with McKinstry Co., along with Seth LaRiviere from McDonald Miller and Richard Warner with Holmberg Co. And today we wanted to present out on our technology known as photogrammetry. This type of approach, this type of tech is instrumental in being able to not necessarily predict, but know what you are about to get into, whether it's from the sales and estimating point of view, the safety side of the house, or any QA QC function as well. With that, I'd like to pass it over to Seth to walk us through how this type of technology allows him and others like him to be much more efficient and effective at what they do. Seth?
Yeah, thanks, Steve. Appreciate it. So at McDonald Miller, I'm in sales of industrial products, and my region, my area is pretty spread out, and I needed a way to be able to capture some mechanical room spaces and have a visual representation without having to go back to those all the time when questions came up. And I looked for some different options out there, and currently I'm testing Matterport, which you may know from the real estate world. It's very popular, and they're starting to push into the construction world. So what we're showing here is Matterport, although there are lots of other companies out there. Some are much more geared towards the construction world. I chose this one because the barrier to entry was very minimal, and I could do this on my phone or use other options, which I'll talk about here in a minute. So what you're looking at here is, this is called the dollhouse view. This is a space that I recorded or scanned. As we enter into the space, you can see we have a couple of boilers here. You can navigate around within the space. So we can pan around, we can look at components. We have a 360-degree view. We can go straight up, straight down. And we can actually tag different aspects of the model. So here you can see there's a nameplate, and here I tagged in an actual picture of the nameplate because the scan isn't so great. And I can actually click on this, make it bigger, and then you can see. One of the other really neat things about this program is the ability to actually measure while you're in it. So here I'm going to navigate over towards this roll-up door, and I'm going to slide angle. And I can actually come in here and using the measurement tool. Well, actually, you can see one I already did. So you basically pick a corner, drag it to the other corner, and here you can see we're, hit it on the same. It would be the same measurement, so you can get your measurement. So it's really great for estimating. It's great for going back and looking at what did I look at. Is the thing going to fit inside the room, or just quick estimating. This isn't a replacement for your BIM or your actual laser scans, but it's accessible. It puts it in the hands of your average salesperson for a fairly low cost. Now, before I jump into the specifics of hardware, I'm going to throw this to Steve, and he can talk a little bit about its use for safety.
Yeah, thanks, Seth. As I mentioned right at the beginning, knowing what we're getting into with regards to the project, being able to pass along knowledge of that space, or to be able to simply coordinate what we're going to do to afford our workforce a safe and healthful work environment, is truly one of the greatest aspects of this type of technology. From a safety point of view, being able to see the site, perhaps geographically remote from where you work, and be able to walk that employee through some of the identified hazards, the potential hazards, and then move on to how we're going to address those. Can we eliminate them? Can we control them? And one of the great examples here is, as Seth zooms in above this boiler, if work on this boiler was part of the task that we were going to do, perhaps fall protection is going to be required. And being able to start getting our minds around potential fall protection anchor points, starting to see if there is space for other means and methods to do the work, perhaps ladders, aerial or scissor lifts, other mobile elevating work platforms. This could also be expanded to identifying other known hazards in our industry, confined spaces, live electrical work, perhaps unsafe conditions on the site. And it allows us all to come to the table before we're ever exposed to those potential hazards and start developing that game plan. And that is truly, in my mind, one of the greatest aspects of how this type of technology would benefit our industry as a whole. Likewise, the QA/QC portion, Rich, can you walk us through that aspect?
Sure, thank you, Steve. Yeah, my name is Richard Warner. I'm the quality manager and business process engineer over at Holmberg Mechanical. The way I like to think about quality with a tool like this is because few of us have photographic memory, taking a record of the work product at a certain time from as many angles as possible can let someone who's checking for quality gain extra insight into what might otherwise be distance or time limited access. So unlike a factory assembly line, construction quality auditing, it doesn't arrive at convenient stations or at set intervals or in batches for someone who's auditing or checking the quality to perform their activity, their test, or their audit. Instead, audits of construction installation have to be mobile. Auditing is brought to each location, element, or instance of the installation. So the assembly line moves and the work product stays in place. So to be effective, quality checkers have to identify which stage of the assembly that they're reviewing in order to make their conclusions relevant. There are 6 stages of a construction audit that can be identified. The first is when something is not ready. So if an element or location is not ready, work can't begin yet. And this can be because a predecessor task is incomplete. That's usually the case. Another condition or stage that can be identified is when work is incomplete. And that can either be because it hasn't begun yet or because it's begun but it's not finished. Any conclusions that are made about incomplete work, of course, have to be tempered. Another possible stage is when something is complete and there's no flaws in it at the time of the initial audit. That's what you're looking for. And then things can be incorrect. That is, they're completed, but they have flaws, whether that's in the material or in the activity of putting that material together, installing it. And then finally, items can be corrected. That is, they were incorrect, but they've been made correct through follow-up. It's important to keep that distinct from items that are complete and correct from the outset for your statistical analysis. And then the 6th condition is not applicable. That's if you're looking for something that shouldn't be there. So you can tell yourself from the outset that you don't need to check for it. There are technologies in place with AI where they're getting better and better at being able to identify from photos what is being viewed without human interpretation, manually looking at everything. But having a record of a given space that you're checking for quality can be instrumental and very useful down the road, both for covering to show that you've done what you said you would do, and also to look for potential impacts and things you want to try to optimize for your team. So those would be some great uses and have been some great uses of 3D photos. So back to you, Stephen.
Well, I'll pick it up from there. Thanks, Richard. Yeah, so this is, like I said, this is Matterport, and the way that this scan came about, there's you can get into this with a simple iPhone. You take your phone, you download the app, you go into a space, and you basically hold the phone up, and it walks you through the scanning process. Each scan takes about 1 minute. You work yourself in a 360-degree circle, and then you do it again with the camera in a slightly different angle. I did several of those scans, and then I moved into a 360-degree camera. Here's one. This is an option. This is a Insta360 1x2. Insta360 1x2, and it's got 2 lenses, so you can see a lens here. This one actually does a little over 180 degrees in all directions, and then this camera here does the same thing. And so this came with a tripod. This is a little tripod here that extends up to about 5.5 feet tall. You set it in a room and you stand kind of around the corner. Yeah, you hit the button on your phone and this scans the room. And then you move it roughly 4 feet, 5 feet, and you do it again. And you can see in the model here, you can see these white circles. These are where I actually did my scans. So you can see about how far apart they are, because you have to be able to capture all the way around objects. So this whole room here took me probably 10 minutes, maybe to scan, and then you upload it to the cloud and you have a working model. So pretty cool. It can be shared out. From here, you can export this to different types of files. You can actually export it into Revit, Autodesk. You can do it as an RVC file or DWG file. There's options beyond just this, what we're using it for, if you actually wanted to integrate it into your detailing program. Some other companies that are out there that we're looking at there's OpenSpace. They're very much geared towards construction world, towards the MEP. There's Constructible, which I know some of our companies are using within the Puget Sound or starting to use, and Cupix. So those are 3 kind of leads for you to follow up on if you want to take an extra step. Steve?
Thank you both. With that, we appreciate you taking an interest in the ever-evolving world of technology. As hopefully was evident in our quick little report out here, there is great opportunity ahead. Photogrammetry is one of those tools in our toolbox at this time, and it's only destined to get more effective and a better product and user-friendly. So thank you very much, everybody.
Thank you.
Thank you.